ويبينار. هذا الويبينار الذي هو جزء من سلسلة ورش عمل كنا قد بدأناها في 14 أكتوبر مع غرفة الرياض. خلال هذه الورشة سنقدم أحدث حلول وتقنيات فحص ومراقبة إنتاج وجودة المواد الصناعية والإلكترونية. So we are organizing this workshop with our partner Elcom from Czech Republic. Represented by Mr. Jan Sima, Head of the Research and Development at Elcom. Mr. Jan, can you please mute your mic first, just for us to... There's some background noise, I guess. Okay. So we are organizing this workshop with our partner Elcom from Czech Republic, represented by Mr. Jan Sima, Head of the R&D at Elcom. المحاور التي سنتطرق لها اليوم or agenda هي كالتالي: حلول NTS باستخدام أحدث أنظمة الفحص القائمة على الإشارة في تصنيع كميات كبيرة من الأجهزة الميكانيكية الإلكترونية. حلول فيجن للفحوصات المعتمدة على الرؤية في تصنيع كميات كبيرة. حلول تسجيل البيانات HSDL للعمليات المستمرة. So next slide. So سأبدأ المؤتمر بالتعريف عن شركتنا. نحن شركة سعد لأنظمة التطوير والأبحاث. So we want to be your trusted partner in your technology journey. So we are your technology advisor and solution provider that build world-class innovation ecosystems to solve complex problems. So we are delivering cutting-edge sustainable productivity solutions to industry. We are bridging the gap between industry and academia. So we want to deliver on our commitment while creating value and social impact. Next slide. So in this slide, we want to explore and discuss potential areas of collaboration with you as industrial sector, and to show our latest testing and monitoring solutions of the industry that can help you automating your production test while bringing new revenue streams for you as industry, engineering integration companies and end users with the help of SAB, RDS and Elcom, while accelerating the journey towards your strategic objective and the Kingdom Vision 2030. So as you can see, we are delivering with Elcom the IP development with the vertical domain expertise needed and the open platform, along with you as local integration companies and industry, while localizing your solutions, your system integration plan, and your local capabilities, so we can work together towards a customer-defined system, like an end user. Maybe could be Saudi Aramco, could be SEC. So this is just examples of potential collaboration with you. So we want to align with Vision 2030 and the total value added program, the In-Kingdom Total Value Added Program, IKTVA. Okay, so now I will give the mic to Mr. Jan, who will be delivering the agenda. Also, before starting, feel free to reach out to me during this, after the presentation, if you have any question, by email, by phone. Also, we can answer all your questions. You can write down them on chatter, so we can serve you. Now, Mr. Jan, the mic is yours.
Thank you very much, Michel, for this introduction. Hello, everyone. I hope you are enjoying your day. And let me continue in this presentation by... Why it's not moving forward? Slides are not advancing. Okay, by saying a few words about our company, Alcom. It is an electrical and test engineering company based in the Czech Republic. It has a history of 30 years, founded in 1990. I started to work for the company in 1995, so I'm very long with the company for a very long time. It's a medium-sized enterprise with about 15 million euro annual revenue and almost 200 employees. We are operating in several locations in the Czech Republic, different parts of the company working in different locations. The headquarters is in Prague, the capital city of the Czech Republic. We're focusing on many different aspects of test and measurement, and some of our capabilities are listed on this slide. Alcom is quite strong in optical systems and light measurement. We are one of the leading companies as far as car headlamp testing for the automobiles. We are also very strong in sound and vibration testing and measurement of the mechatronic products like car HVACs. We are doing haptic measurements, which means measuring force and torque of the control knobs on the front panels of various devices like car air conditionings, radios, but also household equipment. We are strong in industrial automation, usually in some cooperation with the testing part of the system. So if there is a production line or robotic system with some test and measurement aspect, then it is a good project for Alcom. Hardware in the loop testing, testing the ECUs for cars. Then we're strong in testing of electrical motors, measuring voltages, currents, powers, efficiencies, cosine, phi, and such quantities. And we have a power electronic part of our company, which specializes in some special power supplies, which among others are also used for testing the electrical motors. So we have some synergies there. And last but not least is the power measurements part of the company, which is involved in designing power measuring instruments used in power distribution grids, and also the software that is supervising these instruments. These are some of our characteristics products with the pictures. Alcom is quite strongly following the trends set forth in the Industry 4.0 initiative, specifically in the areas of big data. Our measuring systems are producing a lot of data of different levels of detail, and we provide a lot of analytic tools for analyzing these data. Then advanced robotics. So many times the robots are part of our test systems by providing either directly the testing impact, like for measuring the force of the control knobs, or by moving the sensors around the product to be tested. And also a new trend of artificial intelligence is becoming important, and we are recognizing this trend. And one of the solutions that I will present today is also in the development, the part of the solution which is using the artificial intelligence. So we don't have a shipping product yet, but it's soon to come. This is another part of the company which is not so much related to what we are talking about, but just to give you an idea that we can also design special power electronic circuitry and build products around it, which we are doing, of course. This is an overview of some of the key customers that we have. You see a mix of companies from automotive industry, electrical industry, and power transmission distribution industry, and some of the heavy industries like Capco, which is a chemical company basically, or Otis, which is a lift company or elevator company. My first topic will be Nts System, which is used for mass production of complex mechatronic systems. And the reason for Nts existence is that it can detect dead parts in high volume series production of mechatronic products using their physical signatures, so the signals that the products produce. There is an overview of the key features and potential applications. It's an end-of-line test system, which means that usually Nts is applied at the end of the production line on the test station, where the products are tested before they are shipped to the customer. As I already mentioned, designed for high volume testing with average rate or cycle time of the line of about 1 minute. We are using multiple different sensors, and we can measure on several or even many channels at the same time. The frequency range of the signals that we are capturing is within the frequency range of typical mechanical, thermal, electric, or magnetic phenomena that can happen inside of the tested product. So we're talking about the range of up to tens of kilohertz of the active signals frequency. And we already discussed the Industry 4.0 that we are trying to implement all the main characteristics of Industry 4.0 into the Nts product. As far as the applications, we have strong applications in automotive industry for HVAC testing, but there are many other mechatronic systems which are part of the car in automotive industry, which can also be tested by Nts. And then there are also other industries, manufacturing industries, which are producing other types of products, mainly for house use, like HVACs, white goods, power tools, garden appliances, etc., which at the end of the production line can be tested. And because they have their own source of motion or power, they produce sound, vibration, potentially other quantities like force or torque, for example, in the case of drills. So these all can be tested by Nts. The basic principle of Nts is that we acquire signals using various sensors, in this case, microphone. We convert the signals to numbers inside of the computer, where in memory we have then a waveform representing the physical signal. Then we are using some advanced mathematical operations to aggregate the many data points of the original raw waveform into just a couple of numbers representing the behavior of the tested product. And then these aggregated numbers are compared to the limits, which is the red curve in this slide. And if the aggregated values are inside of the limits, then the product is okay. If outside, the product is not okay. The context of the Nts system within the test machine is quite similar to what you can see with the vision systems. Today, vision systems are very often part of the test systems for many different types of products, small, large, very simple, like a piece of plastic, but also very complex, like a car engine, for example. And the Nts is kind of a complementary system to the vision system, where we can catch some of the things that are not visible to the vision system, but the principle of how you install the Nts, how you configure the Nts, how you integrate the Nts into the larger picture of the complete machine, and the way how it's used in the series production is very similar to the vision system. There is some small comparison of the vision system and Nts, where the vision system can capture some of the faults, but cannot see inside of the product unless it's an X-ray system. But X-ray is very dangerous, so it's not very welcome in the factories unless it's on critical infrastructure. And also Nts is testing the product when they are at work, which means that at the test station, at the end of production line, the product is put into operation, the motor is started or some servos start moving, and the NTS is sensing the vibrations, listening to the sound, sensing the force, torque, whatever other quantities. And this way is covering some of the tests or behavior of the product which cannot be covered by the vision system. So the increased test coverage is a key point of this slide. What it looks like, the NTS, it comes in several form factors. The most standard one that is the most popular or preferred is the rec form, where all the components of NTS, which includes digital analog to digital converters, computers, backup power supplies for sensors and other circuitry, are all concentrated in a cabinet, and only the sensors are installed very near the tested product and connected to the NTS cabinet with cables. So that's the rec form, which is the most popular. Some customers are willing to install the components of NTS into their existing machine or machine being built for various reasons. For example, they already have a place dedicated for these components, or they don't want to have another rack nearby. So then we deliver the system in so-called kit form, where you receive individual components, and with help of Elcom engineers, you install the components into your test solution, and we help you to make it work within your context of your factory or your production. And the most complex is the machine form, where we build a machine around the NTS machine, which moves the tested product, which starts operation of the tested product, which basically is a standalone testing device, which performs the complete end-of-line test. As was already evident from the previous slides, NTS consists of the sensors, of the data acquisition hardware, of powerful computer, and of the backup power supply. And the component which is combining all these hardware elements together and creating the NTS functionality is the software developed by Elcom, by our company, which represents the NTS functionality itself. It's been developed for many years, the NTS software. The current shipping version is a third generation of this software, which we have been shipping since about 3 or 4 years, and it's still under development. So I would say every couple of weeks or months we are releasing a new version with improved functionality. I talked about different sensor types and signals. So this is just an overview of typical sensors that are often used with NTS by our customers. So most of the sensors are from the sound and vibration field. There are also rotation speed sensors, non-contact, based on magnetic field sensing, force and torque sensors, and some of the electrical quantity sensors like Hall effect sensors for measuring very high currents. We can process also direct inputs, so measuring voltage and current, because the tested product may have to be powered, and usually by electricity, which means that we want to measure this electricity to make sure that the product is operated at the correct conditions. NTS is highly scalable, which means that we can measure one channel, but also many channels. We can use one computer or many computers depending on the computational load created by all the calculations configured for this given task. There is also a flexibility in terms of how are things split between the individual components of the NTS system as far as how many calculating cores are running on the same PC, how many data acquisition units are used, and how many test stations can be served by various scenarios. It's very flexible. The software can accommodate any of these architectures. As I mentioned, the ELCOM's contribution to the NTS, as we are not manufacturers of the sensors or electrical cabinets, this is the role of the big companies producing these. But as I mentioned, the key contribution of ELCOM is the software ecosystem, which consists of about 7 or 8 software applications, which are helping or are used by the users or by NTS in various stages of the life cycle of NTS or of this production. There is an application to configure everything at the beginning. There is a dashboard application which allows you to help to operate NTS even if the rest of the machinery is not ready yet, specifically the control PLC or PC. There is the core, which runs during production. There are some report viewers and production statistics analysis tools, which help you to monitor the production, discover discrepancies or values out of range, which need to be traced to the root cause, which is can be very well done by our software, because one of the main focuses during the design was focus on visibility of what's happening with the product during the test, and also on productivity, which means how can I easily find the phenomena I'm looking for among thousands of recorded files from thousands of testing units. The software architecture, apart from the ELCOM written software, is also using some of the software components which are produced by manufacturers of the hardware elements that we are using in NTS. This is specifically the National Instruments Max software, which is a driver and configuration interface for data acquisition hardware from National Instruments, which we are using. And vibrometer panel from company Polytech, which is producing the laser vibrometer, which is a contactless vibration sensor quite often used with NTS. And this software is slightly integrated into the NTS software architecture. We can export test results in form of XML files, for which we provide viewing applications, but you can also produce an Excel file, which can then further be processed by people who are very skilled in working with Excel. The software itself is a standard Windows software, which is very similar to any other executable software which you download from internet and install on your PC, and it works. It is developed in LabVIEW from National Instruments. When we are delivering the NTS system, the software comes pre-installed on the PC, which is a part of the delivery, with all the configurations prepared for the specific task that the customer wants to execute on his test machine. We have also installed packages for download, which means that in case of upgrades or using additional applications from our software package, users can run the NI package manager, which is a kind of software distribution tool for software coming from National Instruments ecosystem, and install on your notebook or any other computer some of the tools that we provide with NTS. There is a license key which protects the software from misuse, where the license key is applied to some of the software applications that are part of the NTS software ecosystem. Typically the ones which have to run on the NTS PC, because they have some relation to the hardware and are really used for the actual testing. some small tools, software applications do not require the license, and you can use it on any computer without any license key. Just download and run it. As I already mentioned, NTS is a software which is still under development, which means that you get a new release of software every month or couple of months, and we are encouraging our customers to upgrade their NTS software because they get new, better functionality with the upgrade. Integration is very simple. I already mentioned that you don't have to modify the machine heavily because you just install the test machine heavily because you just install the sensors, which usually requires some holders for the sensors, but not, which are very tiny parts, not requiring major structural changes to the test machines, either existing ones or the ones being built for the new type of the product. The communication between the tester control system and NTS is very simple. It is based on TCP/IP protocol using text messages, which are human readable. So it's super easy for anyone to implement the communication between the supervising PLC or PC and NTS. There is great visibility, and the commands are easy to understand. So we have many systems where the customers develop their own communication with NTS, which consists of selecting the proper configuration for the test, starting the test, and reading out the result. It's very simple. It can be implemented within hours. This is the integration model, what the tester control system does and what the NTS does. So this is basically what I already mentioned, that the tester control system has to put the tested product into operation, and then NTS in parallel, receiving the start command from the tester control system, starts recording the signals. After the DUT completes its operation, for example, one of the operational modes that are to be tested, then NTS calculates the results, tests the results against the limits, and returns the results back to the control system, which is then deciding what to do with the OK or not OK part. Here is some overview of the signal processing that's available in NTS. You can configure any channel using any sensor to perform any mathematical operation from the given set of operations. You can even do these operations in parallel on the same channel or even on multiple channels. So from the same channel, you can calculate several different quantities, and you can do this for many different channels. And each of these calculations which you perform have many parameters. So in total, you have hundreds of parameters which are theoretically available to someone who would really want to use the capabilities of NTS in full scale. Normally, of course, you work with only just a few parameters which are necessary for common types of products or common types of tests. So you can think of NTS as a measuring instrument. It's like an oscilloscope, but it's aware of the industrial context, working with the serial numbers, working with the part numbers, working with the cycle time awareness, providing diagnostic features, etc. So it means it does not control the test machine. It does not control the test product. It's really a measuring instrument which can be calibrated to certain traceability standards so that you can trust the results of the measurement. We were supposed to have a software demo, but I'm looking at my watch and it seems that we will not make it. So I'll just quickly flip through these slides showing some of the screens of the NTS software. The NTS core is the main part of the software which runs on the PC during production, and it shows some of these windows which show the basic status of the system, some log which is scrolling as the production is running, and it can show some measured quantities from selected channels. But normally no human operator is expected to stand in front of the PC monitor and look at the graphs or any of these screens during the standard production if nothing is happening. The NTS core is fully autonomous, so it communicates with the supervising PC or PLC, and it doesn't require any human interaction. The configurator configures all aspects of the NTS, so channels, calculations, limits, and etc. It also gives you some, I would say, helping tools to understand how certain settings influence the results of your measurements. So you have sort of a preview of the measurement. What would it look like if I change this setting? What the result would look like if I change this setting. This is very informative for quality engineers working with the NTS. Dashboard is a tool that you can use if you don't have the communication from the supervising PC or PLC ready yet. So even then you can still take some measurements with NTS by controlling manually by operator the screens of this software. And then there are those offline tools where you can view data in all kinds of graphs and structures. You can filter, search for serial numbers, part numbers, various quantities. You can modify the graphs to expose the things that you are looking for. So it's quite extensive software. You can deeply analyze all the features of the signals that you have acquired for some in-depth analysis, or maybe comparison with the laboratory results that were taken by people working with the laboratory measuring equipment. Backup and restore, it's a very important part, because in production you don't want the production stop because the computer broke down. So if you bring a new computer, the backup bundles created by this application are quickly restored on the new PC, and you can restart the production within some 10-20 minutes, let's say. NTS uses some file format for the results, but these can be converted to several other popular formats so that you can exchange the data with systems from other companies, typically with the laboratory equipment manufacturing companies, which are using their own data formats. Some of the batch processing capabilities also, if you want to see the effect of the calculation setting across multiple serial numbers, so to speak. So the summary, and NTS contributes to total quality management. The return on investment is very favorable because it prevents from the bad parts being shipped to the customer with all the financial consequences, and also it limits the cost of scrap because the scrap rate is controlled by the features of the NTS. In case if there is a human operator listening maybe to the products, then the scrap rate is really depending on the mood of that person. Easy integration, and we acquire a lot of data which can be, by using various NTS tools, converted into valuable information. We have some additional expertise because we are doing this since 20 years, so we can build all the machines and sound boxes and other things. Here are some examples what it looks like in the factory when the system is installed and what the machinery around looks like. On the left, this is the NTS cabinet. On the right, this is the tested product, in this case, automotive HVAC. And this black ball on the right side is a microphone, which is listening to the product. There are other sensors hidden, NTS sensors hidden behind this HVAC, so you cannot see them really in this picture. We have two main big customers, which are both large companies that you might know. Valeo is our biggest customer with 50+ systems installed in the last 10 to 15 years, and Denso also a very big customer with installed base so far only in the Czech Republic, but we are working on extending beyond the Czech Republic with Denso, and of course looking for other partners. We have also some smaller customers, but they are localized here in Czech Republic, so you may not know the names. Okay, so this was the end of the NTS presentation. Now the second part, which is Vision, the vision system. I already talked about the vision system being used in production testing. So we also have one, like many other companies. So I will not spend so much time on Vision because it's not our main product, so to speak. Our main product for this factory testing is NTS. So Vision is doing image acquisition and processing in production. So the product is at the test station for 1 minute, let's say. We have a number of cameras taking pictures and finding in the pictures if the product looks as it should look. Vision components, its lenses, cameras, lights, frame grabbers, computers, and the software. We are using third-party components for all of these from leading manufacturers globally, leading manufacturers. This is some overview of the types of the components that we are normally using for a vision system. But our advantage is that because we are not a manufacturer of a vision system, we can choose whatever components we like or we think are appropriate for the given task. We don't have to use the specific Keyence or Basler or whatever component if it's not really up to the task. So this gives us much greater flexibility, but the overall architecture and philosophy of our vision system is still the same regardless of the components. The software, we are using NI Vision Builder for automated inspection as the main engine of the vision system called Vision. We are also using some additional software and components, specifically the VB Sim, which is the component which connects the Vision Builder to supervising control systems. And that's a unique part because this makes this vision system very open and easy to integrate into any test machine. Again, software architecture, which shows the role of the VB Sim software component, which is an interface between the control system of the tester and between the rest of the vision system. The development of the inspections, so the specification of how you want to test the product is done in the software called Vision Builder, which is from company National Instruments, which is a global big company. Elcom is a golden partner of this company, which means that we have a long-term relationship and we know very well their products. This is our contribution to our vision system, the VB Sim component, which is this interface between the control system and the vision system. The next part and the last part of my presentation is high-speed data loggers or high-speed data logger, which is Elcom product focused on high-speed recording of multi-channel data. The difference between high-speed data logger and all the both previous solutions, NTS and the vision system, is that NTS, for example, is recording the data only for a quite short period of time during which the tested product is in operation, while data logger is continuously recording the signals forever, which means it's used for continuous processes, water treatment, oil and gas, steelworks, gas industry, chemical industry, wherever you have a continuous process which lasts weeks and months and years. We can record up to 300 channels per cabinet. So a high-speed data logger comes in form of cabinets always, and approximately about 300 channels can fit into one cabinet. The sampling rate per one channel is about 10 kilohertz, which means that the recording rate of high-speed data logger is much higher than a recording rate of common control systems of any continuous processes. So you can have a control system based on, for example, Siemens Simatic PLC, but this can record the data at a rate, for example, 20 or 50 samples per second. But high-speed data logger can capture signals at a speed of 20 or 10,000 samples per second from every channel, from many channels. The recorded data are time-stamped using GPS, so their position in time is absolutely defined. And the main purpose of high-speed data logger is monitoring processes which have some quick phases. And for the quick phases, where some quantities are changing very rapidly, much faster than the PLC can capture, we can create some online event detection to capture these events of fast changing quantities and make a detailed zooming into the signal curves to understand the phenomena and eventually debug the process or find the root cause of the problem which is occurring in the process. This is an overview of high-speed data logger. So as I mentioned, there is a cabinet, which is the key part of the NTS. There is an operator console, which is a big screen LCD monitor, which shows all the screens of NTS. There is a time-based source, a GPS receiver, which provides the time-stamping information. And there are connections to all the sensors in the field. And eventually there can be a connection to other systems, typically the PLC control system of the technological process. High-speed data logger is very flexible as far as signal types and counts. So we can measure any electrical voltages, currents, resistance, typically in the standard industrial automation range, 0 to 10 volts and 20 milliamps. You can also process thermocouples, RTDs, sound and vibration sensors, strain gauges to measure mechanical strain or force and torque, digital signals from any kind of equipment with any kinds of levels. And we can also power the sensors. So if there are dry contacts, then we can power them. We can provide IEPE sensor power to microphones or accelerometers, or we can provide excitation voltage for the bridges. A powerful feature of high-speed data logger is the mathematical channels. So you can create a combination of existing physical channels, some temperatures or flows or valve states. And by creating a formula, you create a new mathematical channel, which is calculated on the fly. And this channel can then be a subject of event detection, which gives you a great flexibility in detecting events happening in your technology. We are storing very large amounts of data, terabytes, because you can easily calculate that if the sampling rate is 10 kilohertz and you are measuring on 300 channels, then you are producing about 1 terabyte of data per day. So typically a part of the cabinet is a RAID storage server, which stores all the data from all the channels. And it works in a FIFO manner. So the oldest data get rewritten by the new ones, but we have a decimation algorithm running, which decimates the original high density data to lower density data that are kept for a longer time. But for the period of time when we still have the high density data stored, you can zoom in and out in the graphs of the high-speed data logging software through multiple orders of time resolution, which we calculated as 12.9 million times. You can increase the time resolution from the highest level view from the lowest level view in the graphs. The software consists of several modules which can run on different computers in order to distribute the computing requirements. Online module is used for everything that runs at real time. Offline module is used for everything that can be done offline, like all kinds of data management and configurations. And then there is the analysis module, which makes a detailed analysis of some of the recording signals. Because it's for industrial environment, we want to control who is working with which part of the high-speed data logger, which means that we have different user levels for users to log in using their individual usernames and passwords, and they get access to different screens of the high-speed data logger in order to block people with lower knowledge from some critical settings that they could change and compromise the operation of high-speed data logger. These are some pictures from the reference application in Qatar, Capco petrochemical company, in the low density polyethylene plant. We've delivered several of these systems to this customer. This is another example of a lightweight high-speed data logger, which was used to monitor the construction of one of the bridges across the Moldau River in Prague, which basically measured the tension in the bridge construction during lifting up the bridge from the provisional piers. Okay, that's it. I think we've made it on time. We have some 5 minutes for discussion or questions, if you have any.
Thank you, Jan, for this nice presentation, where you have covered the NTS, non-destructive test systems, the vision, and high-speed data loggers. We are also broadcasting this webinar on the Chamber of Riyadh Twitter, okay, and on Sabah channels. Also, okay. If we got any question from them, we will let you know. In the meantime, we have a question from Mr. Tariq Kamar. So he's asking if we can get, if we can download as customer this trial version of the software. Is there any chance?
I was presenting basically 3 software systems. So are we talking about which of these 3 systems? Any of them, or?
I guess the NTS, because he sent a message while you were talking about NTS.
Mm-hmm. Well, for the moment, we have some components that we can arrange how we can download it easily, but it's only some of the tools that complement the complete NTS software, but the core part cannot be downloaded and tried on a notebook because it requires the hardware. So
okay. So you mean here that a hardware is required, and there is no like full compatibility or functionality when using only the software alone, right?
No, this is something we are looking at, and we're trying to create something, but because it's really for production, it's not so easy to reproduce the kind of production context on your notebook for the software to run in a meaningful way. So it's not so easy like with some, you know, picture drawing software or something like this. So But
Okay.
if there is really an interest, we can arrange something definitely to maybe help the customer to install something that makes some sense.
Okay. So Engineer Tariq, we can reach out to you offline after the session, so we can assist you and get more details about your application and see how we can collaborate. So we are ready to serve you. We will get your contact details. Also reach out to me by phone or by email so you can get your attendance certificate, and we can answer your questions if there is any upcoming projects or needs. I hope this helps. Okay, excellent, excellent, Mr. Tariq. Thank you for sharing your contact details. Any other question? We will be having, we have recorded this session. Also, we will reach out to all attendees and to the people who registered, but they were not able to attend. Also, we will share with them the content of this webinar in case they need to rewatch the webinar again and get the information. We will thank you, Dr. Ali, for organizing this call. Thank you, ELCOM team. We will keep in touch since our event reached its end. Thank you for the questions, and we were honored to have you in our event. This is a series of events. We started it on October 14, 2 weeks ago, and we got good feedback, and we have provided you with the power quality ELCOM and SAB platforms. We will be more than happy to hear your problems and provide you with the right solution. Have a great day. Thank you all.
Thank you, everyone.
Thank you. Bye-bye.